Hello everyone, this is Gowri HS, pursuing my second year BE in the Department of Computer Science and Engineering in Sri Venkateswara College of Engineering, Bengaluru. Today I am here to discuss with you about the subject called Analysis and Design of Algorithms. In that, we are going to discuss about topic called Kruskal's algorithm. Introduction. This algorithm is popular method for finding the minimum spanning tree of a connected undirected weighted graph. This algorithm operates by sorting all the edges of the graph and adding them one by one to the minimum spanning tree. The algorithm ensures that no cycles are formed while adding edges, which is crucial for maintaining the tree structure. Key concept. A minimum spanning tree connects all the vertices in a graph with the least total edge weight. The algorithm uses a greedy approach, which means it makes the locally optimal choice at each step. Understanding concepts like graphs, edges, and weights is essential for grasping Kruskal's algorithm. Algorithm steps. Start by sorting all the edges in non-decreasing order based on their weights. Initialize a forest where each vertex is its own tree and gradually combine these trees at last. For each edge, check if it forms a circle. If not, add it to the growing minimum spanning tree or else skip that one. Implementing Kruskal's algorithm in analysis and design of algorithms. Begin by defining the types of edges and graphs, including the weights and connections. Implement the sorting function for edges, focusing on efficiency and clarity. Integrate the union find structure to handle cycle detection during the edge processing. Example of Kruskal algorithm. Here's a simple example of Kruskal's algorithm using a small weighted undirected graph. We have a graph with four vertices A, B, C, D and the following edges. Step 1. Sort all the edges in increasing order of their weight. Now we have the sorted edges as A to B with weight 1, B to C with weight 2, A to C with weight 3, B to D with weight 4 and C to D with weight 5. Step 2. Initialize an empty minimum spanning tree. We will keep adding edges unless they form a circle until we have v minus 1 which is equal to 3 edges since we have 4 vertices in our graph. Step 3. Edges one by one if they don't form a circle. First, we'll add A to B with weight 1 and it is not forming any cycle, so we'll include this in our minimum spanning tree. Next, we'll move to B to C with weight 2. Even this will not form any of the cycles, so we are including this into our minimum spanning tree. Next, add A to C with weight 3, where we can see that the cycle is formed, that is ABCA. So we'll skip and move on to our next edge, that is D to D with weight 4, and it is not forming any of the cycle, so we are including it into our minimum spanning tree. Now we have three edges, A to B, B to C and B to D. And our final minimum spanning tree have edges A to B with weight 1, B to C with weight 2 and B to D with weight 4. So the total weight of our minimum spanning tree is 1 plus 2 plus 4, that is 7. Complexity analysis. The time complexity of Kruskal's algorithm is primarily determined by the edge sorting step, which is O of E log E. The union find operations can be optimized to nearly constant time, enhancing overall efficiency. Understanding the complexity helps in evaluating the algorithm performance on larger graphs. Advantages of Kruskal's algorithm. This is particularly effective for space graph where the number of edges is much lower than the number of vertices. The algorithm is simple to understand and implement, making it a good choice for educational purposes. Limitations of Kruskal's algorithm. Kruskal's algorithm may not be efficient for dense graph where the number of edges approaches the maximum possible. The need for sorting edges can add unnecessary overhead in certain application. In scenario with dynamic graph changes, the algorithm may require frequent re-execution. Conclusion: Kruskal's algorithm is a foundational algorithm in graph theory which is widely used in networking and optimization. Implementing it in analysis and design of algorithm showcases the capabilities of the language in handling complex data structures. For deeper understanding, consider exploring more advanced topics like Prim's algorithm and graph searching techniques. Thank you for watching.